welcome back to the Tox Lab. I'm Rebecca.
I'm Rob. What happens if you mix methamphetamine, the Prodigy and mice? This week we're going to be looking at a study that tried to explore just that, and also the sensationalist media response that followed. So Rebecca, why don't you introduce us to the study?
So this week we're going to be talking about a study conducted at the University of Cambridge in 2001. And the paper's titled Methamphetamine Toxicity in Mice is Potentiated by Exposure to Loud Music. So in this study, they wanted to assess whether loud music affected how toxic methamphetamine is. It's known that an increased ambient temperature can increase your core temperature, which can lead to more toxic effects of methamphetamine in both mice and rats. So they wanted to see whether this sort of happened with loud music. So for the study, they used music-naive mice. And I kind of feel sorry for these mice, so they weren't able to listen to any sort of music.
Mice that have never experienced music prior to the science.
It's sad. It's a sad life. So they used music-naive mice. They were placed in an open field for 30 minutes to kind of get acclimatised, and then they were given 75 milligrams per kilo subcutaneous methamphetamine injection. And this was chosen because it was the highest dose that didn't kill any mice in the pilot studies. So these mice were then returned to an open field for 3 hours and exposed to 4 different noise conditions. So the first one was silence, which was classed as an ambient noise of 55 decibels. And then they had various loud noise conditions. So they had loud white noise at 95 decibels. They then had their rave music, and then they picked the Prodigy for this. And then they had their loud classical music, and they picked the Allegro movement from Bach's Violin Concerto in A minor for this. Don't know whether that's a personal favourite of the study designers. And all music had been edited to maintain a consistent tempo and volume, was repeated continuously, so there was no variation when the songs ended and things like that.
So methamphetamine, powerful stimulant drug. The Prodigy, iconic rave music from the 1990s. If you've not heard any Prodigy, I do highly recommend you go and have a listen.
Have you got any particular favourite tracks?
I quite like Firestarter, actually.
I feel like that's a solid one.
Which is quite a popular one. They also, though, did have some control variables, didn't they? So they did, as you say, had silence, white noise, and classical music. So we can compare the difference between white noise, silence, classical music, and the Prodigy on potentiating or making worse the effects of methamphetamine. That was the aim of the study. In other words, does mixing methamphetamine and the Prodigy make methamphetamine more toxic?
So they looked at a lot of things with the study. They assessed seizure activity, locomotion in open field. So basically, the area they were in, they divided up into different squares and assessed how often and which squares each mouse entered during the monitoring period. They also looked at stereotypy, which is repetitive movements, which can be like jumping, chewing, circling, and this is associated with impaired behavioural inhibition and negative affective state. And they pulled all their data into 30-minute bins just to make analysis easier. So for the locomotor activity, the control group, which received a saline injection, wasn't affected by any noise. The type of noise didn't matter, and most of them were asleep within 30 minutes of their injection.
So even though they were listening to banging tracks by the Prodigy,
they're just having a nap, chilling out. For the silence or white noise groups exposed to methamphetamine, they exhibited typical behaviour associated with meth intoxication. So they had an initial period of hyperactivity, followed by that stereotypic behaviour, resulting in altered place preference and reduced locomotion. So basically they didn't move around as much, and where they wanted to be within their open field changed. And so this kind of lasted for 60 to 90 minutes before they returned to a hyperactive state.
So they kind of peaked and then crashed?
Yeah, essentially.
So what were the findings? How did it affect them?
So for the mice exposed to loud music, they rapidly became stereotypic and remained so for more than 2 hours. They had a significantly reduced locomotion compared to the white noise group, so they really didn't move around nearly as much. They also had sort of these different repetitive movements, so those exposed to loud music preferred backwards walking and moving in circles, which wasn't seen in the white noise or the silent group. And when they were listening to the Prodigy, they were moving in tighter circles. I don't know whether that's of significance.
Might depend on the track.
It might do. I don't know how many different tracks they used for the Prodigy, whether it was just the one or
I think
repeat.
it said 4, didn't it?
I can't remember now.
I've got a feeling they use 4 different tracks, but they don't tell you which ones.
See, that's kind of annoying because I want to know which ones they used. Within these different groups, mice also showed different place preferences in the open field. So those listening to the Prodigy and the classical music spent proportionally more time in inside squares, and this was significant for the Prodigy group at 30 minutes. And place preference, they believe, is kind of related to like how anxious the mice were feeling. So when they show an increased preference for those like central inside squares, their anxiety is supposedly less. I don't know whether I'd feel less anxious listening to the Prodigy on repeat, personally.
Might depend on your taste.
True. Very true.
Don't forget you're not music naive.
This is fair. This is a completely fair point. And finally, they looked at seizure activity as a measure of toxicity. So some mice in the meth-treated groups had seizures, but this was seen across the different music types as well. So it wasn't just those listening to loud music experienced seizures. There were more seizures in those groups in the mice exposed to loud noise versus silence. And there was also an increase in mortality in these mice who were listening to music versus silence or white noise.
So in other words, the mice exposed to the Prodigy, but also the classical music and the white noise.
Not so much the white noise.
Not so much the white noise, but the Prodigy or classical music did seem to have more seizures.
And were more likely to die from the seizures
And were more likely to die.
So following this experiment, they did then decide to look at markers of brain damage in these mice. So mice were killed on either day 1, 3, 7, 14 or 35 after the experiment had finished. And serial sections of the brain were examined for reactive astrogliosis using a specific protein called GFAP as a marker. And reactive astrogliosis is a defensive response to changes in the central nervous system after brain or spinal cord trauma. It can happen in stroke, epilepsy, and neurodegenerative disease. So it's basically a marker of neurological damage. So in all the mice given methamphetamine, they all showed an increase in this protein and this staining. It was independent of whether these mice had had seizures at any point. So those mice given methamphetamine but were in the silent group, they had maximal damage at day 3, and this significantly decreased at day 7 and was completely absent at 2 weeks post end of the experiment. Those mice who were listening to loud noise or loud music still had elevated levels of GFP at day 7. The white noise group returned to background levels about 2 weeks again, but it remained elevated in all of the groups listening to music, so either classical or the Prodigy. It is important to note at this point that 6 of the mice who were exposed to music had died within 24 hours and their brains weren't examined in this case. I'm not sure why they chose to exclude them.
Seems like a little bit of an oversight, I guess. I'm not quite sure.
I don't know their logic.
Yeah.
Those mice were not investigating any further, so we could be underestimating potential toxic effects of methamphetamine in terms of the brain damage aspect.
In other words, mixing music and methamphetamine is worse than just taking methamphetamine.
Yeah.
At least in this
model.
This
model.
Did they go into why they think that might be? Are there any hypotheses as to what might be going on?
So they don't really discuss why it might be causing more brain damage, but they do kind of go into how the methamphetamine might be altering neurotransmitter release and how that might be altering some of those repetitive behaviours we talked about earlier. So the stimulatory effect of methamphetamine is caused by dopamine release, 5-HT and noradrenaline. So dopamine-dependent movements can include forward locomotion and head bobbing, which was exhibited in the silent and white noise groups. 5-HT can cause something called forepaw treading, which is vigorous movement of their front paws, wet dog shakes, something called straw tail, where they carry their tail in an upright position. And this was only seen occasionally in these mice. Interestingly, both dopamine and 5-HT is needed for the backwards walking kind of effect that was seen with the music groups. So both the Prodigy and the classical music. So you kind of need both those neurotransmitters to sort of exhibit that.
So there are some possible hypotheses as to why this effect might occur. This was a study carried out some years ago now, And at the time of its publication, there was quite a bit of media backlash, quite a lot of sensationalist headlines. One particular headline I've managed to find, "Scientists kill mice with dance music."
Oh, wow.
Which is quite...
it's a leap, isn't it?
It's quite a leap. I mean, I see the logic. Some mice exposed to dance music did die. There was quite a few other quite attention-grabbing headlines that weren't necessarily reflecting the nature of the study. And understandably, there was also quite a lot of criticism from animal rights campaigners. And to be fair, their argument was, we know that taking drugs and listening to loud music is bad for you, so why do we need to do this study? And it's not an entirely unreasonable argument either. And actually, this team were actually reprimanded a bit. They were only licensed to be doing animal work in this context for the study of Huntington's disease. So this was kind of off-license use of their animal house. I guess the question really is this study scientifically justified? And I think it's not clear. It's a bit of a conundrum. On the one hand, there's some really interesting data here, isn't there? That listening to loud, repetitive music seems to make drug toxicity worse. And that's irrespective as to whether it's the Prodigy or whether it's classical music. But there does seem to be something in the sound effect on drug toxicity.
And I guess the big question is how does this translate to humans?
Well, yes.
And whether these effects, obviously you can't test it in the same way, but whether there is any sort of enhancement of toxicity in humans when we listen to loud music and do methamphetamine. I don't know.
Or possibly any other stimulants as well. Yeah. You know, we're looking at methamphetamine, but we know ecstasy is quite often used in rave settings. And that was, I think, the justification for the authors for picking the Prodigy, kind of iconic rave music at the time, the sort of thing that people may well take stimulant drugs and listen to at loud volume. So there was some logic in why these conditions were part of the study.
Well, they do actually say they didn't pick the Prodigy because it's a rave music. They explicitly said that it's picked for its repetitiveness.
The Prodigy almost certainly was picked because one of the authors liked the Prodigy.
Probably.
So I guess with that in mind, maybe there is a bit more justification. I do fully appreciate the concerns raised by those against this study. It's worth pointing out as well that actually the music that they were exposed to was not all that loud, certainly less than an average nightclub.
Yeah, it was 95 decibels, I think.
Which is quite loud. Which is quite loud, but less than the average of a nightclub. So it's possible in real life settings the effect might be more magnified.
That's a very good point.
Conversely, though, they were given huge doses of methamphetamine relative to recreational doses. They were the lowest dose that didn't kill them.
Yeah, they were going to extremes.
Precisely, yeah. So again, how relevant this data is in real life, I guess, is maybe harder to unpick. So looking at the music that was picked for this study, would the results have been different if they'd have picked other music? Jazz, for example. We weren't able to unpick whether it was a specific genre thing or whether it was a repetitive nature thing.
Having the classical music there as an extra control kind of shows that it's just the loud, repetitive music.
The classical music was edited to have the same tempo.
They were all edited to have the same tempo and to be continuous tracks.
It does sound quite stressful when you say it out loud, doesn't it?
It does. It's not the sort of thing I'd want to do personally, but...
And I guess the other possible question that comes out of this then is there a safer level of music? Is this a dose-dependent effect? If the music were louder, would it be worse?
That is a good point.
Thinking outside the box, would there be an alternative way to try and answer this question without using live animals?
Ooh.
We could give volunteers methamphetamine and put them in an fMRI, but
how ethical
is that as well? Yeah, that's a good point.
Go to a rave and look at how people move when on methamphetamine versus those who aren't. But again...
Possible consent issues there.
Yep.
No, it's really interesting thoughts. It really was quite a controversial study. At the same time, unlike a few weeks ago we were talking about Tusco the elephant, which was, again, another controversial study that really clearly was a failure of ethical oversight. In this case, it's less clear, isn't it? The results were interesting. The results were relatively rigorous. I guess the question is when does the value of research outweigh the harm to your animal subjects? And who gets to decide this? So what does this study reveal about the dangers of drug use in high sensory environments? Does it tell us anything at all?
I mean, it's quite hard to translate data from mouse models to humans, but there might be something there that listening to really loud repetitive music whilst on methamphetamine does make it more toxic.
And possibly other stimulants as well.
Yeah.
Thinking about the pharmacology and how they work on, given the neurotransmitter pathways suggested by the authors.
I don't think it's something we're ever going to truly unpick. And I don't know how much it would affect those who are using methamphetamine, whether they think twice about how loud their music was to
Perhaps
potentially
not.
limit their
not.
toxic effects.
Okay, so more controversial question, possibly then. Does it apply to more legal stimulants? Caffeine, energy drinks?
Ooh.
Could it make that degree of toxicity worse? So we're talking orders of magnitude much less powerful than methamphetamine, but
I mean, maybe. Who knows? I don't think it's necessarily something we need to be looking into and investigating.
that's also fair. Yeah, that is also fair.
When reading this study, I was kind of surprised that music made any difference at all to the sort of toxicity of a drug. Like, it's not something I'd truly considered as being something that could happen.
It's certainly not something we consider when we're writing our reports about toxicity of things, is it? For sure.
So that was quite interesting.
Yeah, setting and environment sometimes can be really, really important on the effects of drugs, but actually we don't really tend to give it much thought as to the perhaps scientific basis of that. So I think in conclusion, what happens if you mix methamphetamine, mice and the Prodigy? The answer is possibly brain damage.
But possibly not.
It's hard to argue that the findings weren't interesting, even if the study was ethically a little bit controversial. And it's probably an area we're never going to be able to do follow-up research on, looking at other genres or looking at different volumes because of the ethical implications.
Yeah, and I don't think there's grounds for it.
Certainly doesn't seem justified, does it? Okay, well, I think we're going to wrap it up there. I hope you've enjoyed listening this week. Do give us a like and a follow. Tell your friends about us. That would be even better.
If you want to follow us on socials, you can find us on Instagram at @the_tox_lab. We'd love to hear from you over there as well. If you've got any suggestions for any future episodes, feel free to comment on any of our posts. You can comment on Spotify, or you can send us a DM. We'll try and include your suggestions in future episodes. So thank you all so much for listening. Hope you had a great week, and we'll see you next time. Bye.